based on the shapes of these curves. Not only that, but they all agree. Lead 208 tells the same story as lead 206, tells the same story as lead 207, and they all say that the Earth system, and thus the solar system, started evolving 4.65 billion years ago. So Claire Patterson not only saved us from lead poisoning, he also let us know how old we are. All right, so this is where I talk about you. So hydrogen falls into that category, and some of the helium too. But there are others that aren't left over from the Big Bang, most of them. Some of them are when you take one atom and then you hit it with a cosmic ray, you can make a different atom. So we're all bombarded by cosmic rays every time we walk outside, but if you're an element, this can actually transform your identity. So boron and beryllium fall into this category. And then all the rest of them have something to do with the star. All right? Different stars make different elements. I want to focus in here on dying low-mass stars. Low-mass stars include stars like our sun. And our sun it's not dying yet, but it will someday. And specifically, I'd like to talk about carbon. All right? Carbon's element number 6 over here on the periodic table. The reason I'm going to focus on carbon is you're made out of it. All right? So you should care about where the stuff that makes up your body comes from. All right? I know Carl Sagan told you you're made out of star stuff, but I want to give you some details. All right? You look at the planet Earth, you see carbon all over the place. It's in our atmosphere, it's in our oceans, it's in our volcanoes, it's in our bloodstream. So this carbon, element number 6, comes from a thermonuclear fusion reaction that is taking place today in our sun. So our sun is a giant thermonuclear fusion reactor. It's a short 8 light minutes from here. And it's taking low-mass stars like hydrogen and helium and fusing them together. So in the specific case of carbon-12, the recipe is you need, originally, 12 hydrogen atoms. And if you fuse a hydrogen atom to a hydrogen, to a hydrogen, to a hydrogen, you get an isotope of helium, helium-4. You can squish 2 of those together and make a beryllium-8. And if you take a beryllium-8 and you squish it into a helium-4, you fuse their nuclei and you make carbon-12. All right? So all the carbon that makes up your body was made in this process, which is pretty remarkable, in the heart of a star. So stars blow up, they fling their bits out into space, but this is a very short-lived high-energy event. This is actual imagery of the aftermath of a supernova. You're seeing a light wave passing through a very large amount of dispersed gas and dust in space. This is about 15 years worth of data compiled here into a few second GIF so you can watch it playing out over time. So our nebula must have come from the supernova of a pre-existing star, and if that star was anything like the stars that we observe around us in the galaxy today, or even beyond the galaxy now, it probably had planets around it, all right? And it had its own backstory. So this is kind of remarkable, because it means that we're sort of living in a haunted house, all right? The signatures of this ancient vanished solar system are not only all around us, they are us, all right? You are made out of this obliterated, ancient, forgotten solar system that no longer exists. And occasionally we can find out really amazing insights about this. So let's think about this process. Here's a star, it goes boom, then it makes a big cloud of gas and dust that gradually organizes itself into a new solar system. How long does this take? Turns out we can find the answer here. This is the Allende meteorite. The Allende meteorite fell down to Earth in 1969. It landed in Mexico. You can see it, or a piece of it, if you walk